This next video is really not going to be anything new exactly, just connecting some concepts, which is always a fun thing to do in math. A lot of times we're really focused on the small picture and we lose sight of the big picture. So we're going to talk about cofunctions, and before doing that, I want to remind everyone about complementary angles. And remember that in a right triangle, I have some right triangle, and let's say this is some angle alpha, and this is some angle, let's not use alpha and beta, because we're using them for something different. What about theta and phi? Also pronounced phi sometimes. Theta and phi. Remember that, what's the relationship? Oh, we say theta and phi are complementary. They add up to 90 degrees. Supplementary is add up to 180 degrees. And these ones have to add up to 90 degrees because it's in a right triangle. And all triangles add up to 180 degrees. Okay? So again, theta plus phi is 90 degrees, or pi over 2. So theta is just pi over 2 minus phi. You could subtract phi from both sides and get that these two equations are the same. And so we can combine this with something else that we know. Right? What is the sine? Let's combine this with something in red. What is the sine of theta? Well, if we just label these x, y, z, the sine of theta is opposite over hypotenuse. So it'd be y over z in this case. What would the cosine of phi be? Well, that'd be the adjacent side to phi over hypotenuse. That's y over z. And you may remember this relationship as well, right? The sine of some angle is the cosine of its complementary angle. So if we combine this with this, we're going to get that sine. Hold on, I want to be consistent with the book. Let's subtract theta from both sides. If we subtract theta from both sides, this is what we get. That phi is pi over 2 minus theta. They're both correct and they're both fine, but I'm trying to be consistent with the book's notation to make things a little bit more straightforward for y'all. So we get that the sine of theta is the cosine of phi, and what is phi? Phi is pi over 2 minus theta. This was one of our cofunction identities. Sine and cosine are cofunctions. Sine, cosine. Other ones are tangent and cotangent. Secant and cosecant. All right? And they go in both directions because we could have solved for phi. If we solved for phi, we would have gotten another cofunction identity. All right? And we usually just always say theta, but yeah, so there's a bunch of them. We've talked about these identities before. I think they're also in the identity sheet. There are 6 of them. Just the trig function, sine, cosine, tangent, secant, whatever, of one angle is its cofunction of its complementary angle. We got a bunch of those. All right, and my memory is just dying for some reason, but I'm pretty sure that we've introduced that before. Example 6, prove that the sine of theta equals the cosine of pi over 2 minus theta using the difference formula, using 9.2. So I just showed you in the last page 5 seconds ago why this is true, but we should be able to prove this as well using the angle difference formula. So using the angle difference formula, what is the cosine of pi over 2 minus theta? That'll be the cosine of the first angle times the cosine of the second angle plus, remember cosine, it's always opposite, the sine of the first angle times the sine doesn't start with the letter C, sine of the second angle. So we're going to have cosine of thetas and sines of thetas. We can't do anything with that because theta can be anything. But remember what we know about pi over 2. And it relates to the unit circle. If we have a quadrantal angle, so 0 degrees, pi over 2 degrees, pi degrees, sorry, pi radians, all of these radians, or 3 pi over 2 radians, any angle that lands on one of the quadrants, we can just use the unit circle. This is the point, 0, 1. Cosine is the x coordinate on the unit circle. Sine is the y coordinate on the unit circle. Okay, so what is the cosine of pi over 2? Well, it's the x coordinate there. Big fat 0. What's the sine of pi over 2? That's the y coordinate there. It's a big fat 1? I don't know. So we just get sine of theta. Oh. We started with cosine of pi. Oh, look at this. We did it. We proofed. We proofed. That should be like a sound effect. Proofed. Like a little sound effect bubble. Let's do another one. Example 7. Write the tangent pi over 9 in terms of its cofunction. And remember that all the cofunctions are just adding co or removing co, right? Sine add co is cosine. Tangent add co is cotangent. What's the cofunction for cosecant? You don't add co because then it'd be cosecant, which again makes me want chocolate. In that case, you'd get rid of the co and you'd get secant. So we're going to use the formula that the tangent of pi over 9 is its cofunction, which is cotangent pi over 2 minus that angle. And you just need to simplify. Get a common denominator, 9 pi over 18 minus 2 pi over 18. And we get the cotangent of 7 pi over 18. And that's all it wants us to do. And that's how cofunctions connect with sum and difference formulas for sines, cosines, tangents. Enjoy. Enjoy.